Hi there, my name is Greg Badum, and this is Calculus 2, question 5. So, for this question, we are asked to solve the integral of 1 over x cubed plus 4x. Okay, so the first thing that we're going to do with this problem is we're going to factor out the x on the bottom, which is going to give us 1 over x times x cubed plus 4. Forgot the dx. So, okay, so we're going to factor. And that's going to leave us with 1 over x times x squared plus 4. And since we have two separate values on the bottom and they're multiplying by each other, we're going to use partial fractions. So what we're basically going to do is we are going to set our values a and bx because we have x on this side, which is just to the power of 1, and then we have to the power of 2 over here, so we have an x on the top as well. So it's going to be a over x plus bx over x squared plus 4 equals 1 over x squared plus 4. And we're doing this so that we can simplify, forgot something, 1 over x times x squared plus 4. So we're doing this because we want to simplify the equation so that it's easier to solve. So now we are just going to multiply these values. So basically, we're going to have a x squared plus 4 plus b x squared equals 1. And then if we multiply these, we are going to get, or if we distribute them, we're going to get ax squared plus 4a plus bx squared equals 1. So the problem here is that we don't have an x squared on this side that we can compare this partial fraction to. But the thing is that we have to just put 0x squared because there isn't one there. That solves that problem. So then we're going to have two separate equations based on their value, their coefficient. So we're going to have a plus b equals 0 and 4a equals 1. And from this point, we are just going to solve for each value. So if we divide 4a by 4 and 1 by 4, we're going to get a equals 1/4. And 1/4 minus 1/4 equals 0. So we're going to get the values of a equals 1/4 and b equals negative 1/4. And then from this point, we will erase everything and just rewrite it up here. So once we do that, we're going to have the integral of 1/4 over x, because we're plugging that in for a, minus 1/4 x squared plus 4 dx. And since we have a minus sign here, we can apply linearity and separate the integrals into two separate functions. And since 1/4 is a constant on the top, we're going to pull that out of the first one. So we're going to have 1/4 x dx minus, and we're going to do the same for this one, 1/4 1 over x squared plus 4 dx. And I made a mistake. So basically, because we had a plus bx, we have to incorporate x into this equation as well. So in doing that, we are actually going to have x over 4, now 1 over 4. So once we pull this out, we're not going to have 1 over x squared plus 4, we're going to have x over x squared plus 4. So that's something important not to forget. I almost just forgot it literally right now. So after we do that, this one is really easy to integrate. X dx is just integrating it. It's just 1 times Actually, I made a mistake with this one too. So this is not 1/4 times x. this is 1/4 times 1 over x because you're pulling it out from the top. It's my fault. So 1 over x, when you integrate it, is just going to be ln. So this is 1/4 ln x. And then we have to do u substitution for this side. So basically we're going to do u equals x squared plus 4, du equals 2x. And then since this doesn't match anything, we're actually going to do 1/2 du equals x dx. So now we can plug these back in, and that's going to give us 1/4 ln of x minus 1/4 of, since these two cancel these out up here, and this cancels that out right there, we are going to have 1 over u times 1/2 du, and we can pull this 1/2 out, and that's going to give us 1/4 ln x minus 1/8 1 over u du, and we can do the same thing that we did with this first part, and that's going to integrate to ln of u. So we are going to have 1/4 ln x minus 1/8 ln u. And the problem is that we don't have the same terms, so we have to unsubstitute this. That's going to give us a final answer, 1/4 ln x minus 1/8 ln x squared plus 4, and then plus c, because it's an indefinite integral, and that is how you solve that problem.